Welcome to EDU World Space.
This question asks us to consider the first ionization energy of neon and the electron affinity of fluorine. In part A, it asks us to write equations including electron configurations for each process. I've already done that to save us a little time to discuss this, but here's the reaction for the ionization energy of neon. Neon losing an electron to form neon plus and that one electron. The electron configuration of neon in its normal form is having a full outer shell. So it's helium, 2s2, 2p6. So it has a full s and a full p orbital. Once you remove that electron, of course, you're going to remove it from the p orbital, so you only have 2p5. For fluorine, the electron affinity equation is fluorine gaining an electron to form F minus. So it's pretty much the opposite here. You're going from helium 2s2, 2p5 to helium 2s2, 2p6. You're going from 2p5 to 2p6, gaining an electron and filling that outer shell. In part B, it says these two quantities have opposite signs, that is the energy, the ionization energy, or the electron affinity energy, which will be negative and which will be positive. So which of these is more favorable and which of these is less favorable? We already know that full electron shells or orbitals are more stable than unfilled ones. So neon, or all the noble gases for that matter, having those full valence shells, complete valence shells, are more stable, or the most stable elements in the periodic table. So just from our intuition, removing an electron from a noble gas is probably less favorable than a element gaining one electron generally. And we can look more specifically, neon is to the right of fluorine on the periodic table. That means it has one more proton in its nucleus, one more, therefore having a greater nuclear charge, greater effective nuclear charge, meaning that its pull on its electrons is greater than that of fluorine. So in that sense, removing this electron would be even harder. So all those pieces of information together, it's safe to assume that the ionization energy, which we can write as I1, is going to be greater than 0 for this reaction. That is to say, it's not favorable. And the affinity, right, this is E1, is going to be less than 0. That is, it's going to be more favorable, because fluorine, as we know, being one away from the noble gas, is likely to gain an electron. And then in part C, it says, would you expect the magnitudes of these two quantities to be equal? If not, which would you expect to be larger? So we already know that this reaction, the neon gaining an electron, is less favorable, so its ionization energy is positive. And we said that this fluorine affinity reaction is more favorable. Its ionization or affinity energy is less than 0, but it wants to know, is the magnitude greater? Is this neon reaction more unfavorable than this fluorine reaction is favorable? And for all of the reasons we just described, because neon has that extra proton in the nucleus, higher nuclear charge, greater pull on its electrons, that makes this process difficult. Fluorine, on the other hand, is one away from filling its outer shell and has that electron affinity because of that property. So because neon has this problem with having a higher electron affinity, higher nuclear charge, meaning a greater affinity for its electrons, we would expect this to be greater in magnitude than this affinity energy.